All right, Year 12, I'm going to quickly do a couple of exercise 3.6 for you, particularly for the students who were away, to make sure you're right to get these done next week before you go away. So I'll start with the very first one, and it is vital. It is vital. You must sketch each of these, as sometimes the areas may be above or below the curve, and you're going to have to make sure that you know whether you're finding a positive area or a negative area. So let's have a go at the first one, question 1, which is y equals 1 minus x squared. Now straight away I don't like the way that's written, so I'm going to rewrite that as y equals minus x squared plus 1, which tells me from our days on Desmos or curve sketching that this is just our standard parabola moved up 1. So I'll just do a quick sketch over here, and it's a negative parabola moved up 1. And we know that that's 1, and we know that those two will be the square root of 1, so we get minus 1, and we get plus 1. And what we need to find is this area in here, because the question asks, find the area enclosed between the curve and the x-axis. So now we can use our calculus or our integration, because we know that if we go and do the primitive function between 1 and minus 1 of 1 minus x squared dx, it will tell us the exact area between those two values and the x-axis. So off we go. And this is pretty easy to integrate, so we get x minus x cubed on 3 between 1 and minus 1. And we get 1 minus 1 cubed on 3 minus negative 1 minus negative 1 cubed on 3. And you would do this on your calculator, but I'm going to be foolish and do it without, so it's going to be 1 minus a third, so I'm going to get 2/3 minus 1, that's going to be minus 1 cubed, so that's going to be minus 1, so minus 1 minus, plus a third. And I'm going to go, all right, so that's 2/3 minus 1 plus a third is minus 2/3. And 2/3 minus 2/3 becomes 2/3 plus 2/3, which is 4/3, or 1 1/3, and because we're finding area, units squared. Well, pretty good. Pretty good. Nice and easy, and that's the correct answer. Let's have a look at another one. Let's have a look at question 2. In question 2, x squared minus 9 in the x-axis. Okay. X squared minus 9 in the x-axis. So we'll go over here. X squared y equals x squared minus 9. Well, that's just a standard parabola moved down 9. And it's a positive one this time. And we know that that's 9. We can find these points by letting y equals 0, but smart people will be going, oh man, x squared minus 9, that's just going to be 3, and that's going to be negative 3. If you're going, what? Just do this. Let y equals 0, so 0 equals x squared minus 9, therefore 9 equals x squared, x equals a plus or minus the square root of 9, square root both sides, you get plus or minus 3 is x, and there you go. Now we've got to find this area. So how do we do that? Well, we set up our integration. Area equals the integral between 3 and minus 3 of x squared minus 9 dx. Oh, great. Let's integrate. So add 1 to the power, x cubed over 3 minus 9x between my parameters, 3 and minus 3. Okay, set this up and we go, 3 cubed over 3 minus 9 times 3. Oh, goodness me. Look at that. Minus 3. Minus 3 cubed over 3 minus 9 times minus 3. Okay, go to your calculator. That's going to be 9 minus 27. And that's going to be minus 9 plus 27. So, and that's going to give me minus 18 minus 18 is minus 36. And holy jolly, how do I get? I've got a negative area. What's going on? Remember that positive and negative numbers just tell you direction, and it's of course it's a negative area because it's under the curve or under the x-axis. So you say to yourself, how can I deal with that? What's going to help me deal with that? Well, what we should have done is we should have realized from our sketch that it was going to be under the curve, and we should have just said, well, we'll just take the absolute value of our answer. And if we just take the absolute value of our answer, when we get down to here, we can just go equals 36 units squared, which is the correct answer. Okay, so let's deal with another one. I'm going to do question 10 in a minute, but first I'm going to do 9 and 10. So here we go. Here's question 9. I need the area of x cubed between 2 and minus 2. Okay, oops. Let's just rub that out, because remember the first thing we need to do is sketch it. So y equals x cubed. That's pretty easy. That's a standard. And we're going from 2 to minus 2. And we need the area. All right, no worries. So what do? Area equals between 2 and minus 2 x cubed dx. Okay, that's easy. X to the 4 on 4 between 2 and minus 2. And that's going to give me 2 to the 4 on 4 minus negative 2 to the 4 on 4, which is 2 to the 4 is 16. 16 on 4 is 4 minus 2. Oh, that's going to be 4 as well. Oh, hold on a minute. 0. I can't get a 0 area. I know. Of course it's going to be 0. This area, this is negative, and because it's symmetrical, it'll cancel out this positive area. So, how do I deal with that? Well, you have a choice. You've got two options. You can just go from 0 to 2, so you can find area equals from 2 to 0, and because you know it's symmetrical, double it, x cubed dx. Or you can go the area equals and split it from 2 to 0, x cubed dx, plus the absolute value of 0 to negative 2 x cubed dx. And you go, all right, no worries. I actually like the first method, but I'm going to do this second one because it's going to help us with the next bit. So what do we got? 2 to 0, so that's x to the 4 on 4 between 2 and 0 plus the absolute value of x to the 4 on 4 between 0 and negative 2, absolute value. Well, that's going to be 2 to the 16, idiot. 2 to the 4 on 4 plus the absolute value. Minus 0 to the 4 on 4 plus the absolute value 0 to the 4 on 4 minus negative 2 to the 4 on 4 absolute value. And that's going to give me 2 to the 4 on 4 is 16. 16, that's going to give me 4, and 0 to the 4 is nothing. And here I'm going to get 0 to the 4 on 4, which is going to give me negative 0 minus 4, which gives me 4 plus, when I do that, I'm going to get the absolute value of negative 4, which is going to give me 4 plus 4, which is going to give me 8 units squared. And that's question 9. Okay. So you can either get rid of the negative if it's symmetrical by doubling it, we only go in half the parameters, or splitting the parts that are negative and the positive. So it's going to get a little bit complicated. So let's have a look at question 10. And the reasons 10 is going to be a little bit more harder is it's the same question, but the parameters are different. So let's set it up. Here's question 10. And it's, hold on. It's y equals x cubed, same thing, but between minus 3 and 2. So again, I'm going to draw it. Always draw it. And we're going from 2 to minus 3. So now the areas are not symmetrical. And you're thinking to yourself, well, I can't do that double rule, which is why I did the absolute value one to begin with. So you need to sketch these so you can see what's negative and what's positive. So here we go. The area equals from 2 to 0 x cubed dx plus the absolute value from 0 to negative 3 of x cubed dx. All right, so here we go. This is easy, we've just done it. That's x to the 4 on 4 between 2 and 0 plus the absolute value of x to the 4 on 4 between 0 and negative 3, which gives you 2 to the 4 on 4 minus 0 to the 4 on 4 plus absolute value 0 to the 4 on 4 minus negative 3 to the 4 on 4 absolute value, which gives me 4 minus 0 plus, let's see what happens when we get the absolute value out of here. I'm going to get 0 minus, and that's going to become negative 3 to the 4 is 81 on 4. So I'm going to get 4 plus now 81 on 4. 81 4 equals 20.25. I'm going to get negative 20 and a quarter. They got 25 in the back of the book, so I use that. But it's the absolute value, so I just go plus 20.25, which gives me 24.25 units squared. And that's it. So remember, sketch it. You must sketch the function. Find the area, find out the parameters. Sometimes you'll have to find out the parameters. You'll have to solve it. Find out what parts are negative. Put them as an absolute value, or if you're sure they're symmetrical, you can just halve the parameters and double them. So it's going to take a bit of time to do these. So good luck.